So hi everyone, my name is Shashank Mohan. I'm a PhD candidate at Michigan State University, USA, and I am a PhD candidate in Department of Biosystem and Agriculture Engineering. Uh, that's part of one of the department, Michigan State. So today I'm going to present the advancing water quality monitoring through the integration of machine learning and remote sensing. There are few challenges, there are few innovations, and there are some future prospects what we can think of. Yeah, so before going to that, just a little bit introduction about my university, that is a Michigan State University. And the motto of the university is Spartansville, because we believe that what we can do signifies a kind of a zeal for our passions in research. And it's a big school for football too. And it was inaugurated in February 12, 1855, and it's a land grant university. So most of its grant comes from uh, the funding that the professors and other people generate. It's just some basic things like how it started and how it's named in 1964 as Michigan State University. So just like a basic thing, like my department comes into the College of Engineering and College of Agriculture. It's a part of both the things, so it gets funding from both the college, engineering as well as College of Agriculture and Natural Resources. So it's basically like that. And I'm a part of a group called CECO, and our professor, he is not here today, is Dr. Muzad Hashimi. He is a foundation professor at MSU, and this is our small research group, consists of many people with dynamic backgrounds. So yeah, for the today's topic, it's about water quality monitoring. And sorry about that, I'm much more a visual person. So we all know that we need water for our things, and currently approximately 2.2 billion people are suffering from water problems. And if we go with the empirical formulas, that is the sampling and analysis in the labs, it's a very time intensive as well as a tedious process to do, and it requires a lot of funding. And if you think about a big river, like, let's suppose Nile, or like rivers in India like Ganges and Yamuna, they are quite big and you cannot take sample for a lot of things, right? So to address those issues, in the last decade, from especially after 2010, there was significant efforts being made using remote sensing, and there were many satellites being launched by NASA and other European organizations, and a few of them was Landsat, Sentinel, and all those things, and they were more focused on generating those data and getting those data. But the problem was before, I think, 2014-15, that those data will not make any sense because they are a bunch of chunks of data that has been put into the data centers. But as you all know that recently there was a trend for machine learning, right? We are trying to make prediction, or using the deep learning models, we are also analyzing the futures, like what can go right and what can go wrong. So those data suddenly start making a lot of sense. Like we can take those data and try to implement, like, what are the factors that are mostly degrading the quality of water, and how we can mitigate it. We are not 100% saying that we can mitigate them all, because it's not infeasibly possible. But there are certain parameters of water quality that we can monitor using the remote sensing, that's the satellites, and we can predict it how they're going to accumulate in the long run, and what we can do, to just get rid of them and making the water much more accessible to those 2.2 billion peoples which are lacking, fresh water. So this is a simple slide for that generates kind of methodology, like what we can do, right? As I was talking about that, there are few satellites initiatives has been taken by the NASA, and one of the Sentinel-2. Uh, when it launched and how it launched and what kind of active passive radar they have been using is a little beyond the scope of this today's conference. But if you want to know about more, like, feel free to shoot me an email. My email is mentioned in the first slide. I can get back to you later on. And other one was Landsat. It's a hyperspectral satellites, and MODIS is one of the active passive satellites that been used to collect the data from a water body. And for just making it like little simple, that we have taken like 2 3 parameters as of now, that is chlorophyll A, total suspended matter, and dissolved organic matter, that is part of the water body, and that makes it what you can say that not so pure, right? But just think about in a grand scale. Let's suppose like we have a very big lake or like a river, right? We cannot just keep collecting water like every few kilometers. It's not physically possible because it might take, lot of manpower and a lot of economical things has to be taken place. So, but with those satellites, we can cover a big spatial area, and they have with the data they have collected, they have this kind of prejudices, like like they can make certain assumptions at least for those parameters that I have recently talked about, that is chlorophyll A, total suspended matter, and dissolved organic matter. So what these things do, that these satellites collect those data and put in data center, and we collect those data which are part of the satellites. They are just three, but they are more two, right? Recently, NASA has recently launched a NISAR mission in 2025, and it was quite good with his NASA Jethro active passage mission, and it gives a very a narrow spatial bond for the satellites. And using those data, we can create the machine learning models, right, which are quite easy nowadays, all thanks to the chat GPT and its code writing skills. And we can make predictions like how these kind of parameters gonna affect the water quality, not today but maybe 10 years from now, or 20 years from now, 50 years from now, and what are the measures that we could take as of now to make the situation go from bad to worse in the later scenario, and just try to mitigate it, like as soon as possible, because there's always a say that a cure treated earlier cannot become like very cancerous thing, right? So this is a simple methodology that what we are doing in our research, right? So basically, in machine learning, there are like many models, that is regression model, deep learning architectures. But for the sake of our study, that we have gone for a hybrid model, that is basically integrating the remote sensing data with auxiliary variables that are lastly discussed in that slide about the chlorophyll and total suspended things, the parameters, right? And still, like from older days, that we have the ground truth data already collected with us, right, for for many decades, right? So what we can do, that we are not saying that our model is 100% feasible, that it can predict with a 99% accuracy, but it can goes up to like 50, 60, which is good for like if you're looking such a big area like a river or pond, right? And using the ground truth data, we can always comes with RMSE errors, R square errors, or ME errors, and just try to mitigate it as soon as possible. So the models can predict better with more data, and it gives less and less errors in the coming years. So there are few case studies that this work been done, and the first one is the Lake Taiyuan in China, and the model, the CNN, the convolution neural network model that they have trained, is achieved at least like 89% accuracy in classifying algal bloom, that is basically an algae that accumulates over the water surface. And it can just find also tells us that this is gonna happen like in the long run, right? So you can mitigate thing like if you take actions as of now. And another great example is Mississippi River Basin, and there here, as you can see, they have integrate the Landsat and the render for the forest, that is a regression model, to reduce turbidity estimation error by 32%. Turbidity is basically like how this water is like kind of goes up and down, the turbine like thing, right? Like you can see the waves in the sea. And another great example, that they have used UAV, that is basically drones mounted hyperspectral sensors to map the total suspended gradations at 0.5 meter resolution. Although this is the example that I have put in here, but I cannot say that it is quite good, because the feasibility of a drone or UAV is quite low as of now, because of the lack of the batteries which are being used in lithium ion. But eventually, for mapping like maybe like 20 to 50 kilometers is good thing, right? You can do it. But overall, if you're targeting a bigger area, then I personally believe that remote sensing things using the satellites are much more feasible. There are few challenges and future directions that that need to be addressed to, right? One of things is data limitations, because In the cases of Landsat and Sentinel, they are not mapped parallelly. So let's suppose that on January 1st, 2025, Landsat has created like swiped a particular area, but the Sentinel just swiped the area, same area in January 12th, right? So there's a, I think, 11 days difference between them thing. So that thing that this needs to be addressed as of now, like because they are not synchronous. So we cannot take the data of a particular day from both the satellites and make the predictions. We have to make certain adjustments that on that particular day that Sentinel goes over that area, on that particular day the Landsat goes over the area. So and using still using the ground truthability, then we make certain assumptions. So because of that, the model's feasibility, the machine learning model's feasibility always tone it down a little bit. Interpretability is all another issue that you cannot interpret like one thing to another. It's a little tricky because you have to use certain class of functions in Python and packages and all those things. And scalability, that you have to scale it, right? That you cannot just take out 50 kilometer square area and just keep it as it is. You have to scale it to 500 to 5,000 to 5 million, right? It goes like that. So to address those challenges, there are certain things that we can do. That we can create the next generation sensors, especially in the field of hyperspectral imagery, and we can create the IoT RS based hybrid systems. It is required because a person is not always available. Let's suppose the Amazon forest, right? No one goes there and collect the ground truth data. So we need IoT for the ground truth data, and that is makes much more sense that the dependability on a human being to go to a certain dangerous area to collect the ground truth has been reduced down, and it is a very crucial thing that we can do it, right? Explainable AI is one of the moral concepts that has been debated recently in the case of Microsoft too, right? Where people say that we have to understand what AI is because it's basically a black box, but more about its ethical values, like how much of privacy we can pry on people's uh, people's privacy, right? So that's basically a moral things that need to be addressed too, right? If we go into the future of like remote sensing and machine learning, and climate resilience is one of the factor that it always changes, right? So you never know like what the future holds. So that's also taken into consideration that these are the directions that one need to take for that thing. So in conclusion, that we can say that the scope is there. I have not included all the things that I want to tell because of the shorter duration of the conference format. But uh, these are the things that we can do for the water quality monitoring and how we can mitigate those threats in the longer run to make the water accessible to all the peoples that do not have the fresh water accessibility with them. And yeah, that's about it. Thank you so much. Any questions?